In the silence of space, 48 billion miles from Earth, humanity's oldest messenger is sending back data that shouldn't exist. For 5 months, Voyager 1 went silent. When it came back, it wasn't the same. NASA engineers performed digital surgery across billions of miles of void, reassembling broken code like archaeologists piecing together a forbidden text. But what they discovered in those reconstructed signals has created a problem. The data shows Voyager 1 encountered something in interstellar space that defies every model, every equation, every assumption we ever made about the cosmos. And someone at NASA knows exactly what it means, even if they're not saying it. Imagine you're in a classified briefing room. The lights are dimmed. A scientist walks to the podium and tells you something that will reshape everything you thought you understood about the universe. This isn't speculation. This isn't theory. This is data, raw, unexplainable, undeniable data, coming from the edge of human reach. What you're about to learn is not a story about space exploration. It's a story about a threshold being crossed and what happens when we find something waiting on the other side. Let me take you back to November 2023. On that date, something extraordinary happened that almost nobody noticed. Voyager 1, the spacecraft that left Earth before you were born, the machine that has been traveling through the cosmos for nearly half a century, suddenly stopped talking. Not in the way a dead satellite stops talking. Voyager 1 stopped in a way that suggested something was deeply, fundamentally wrong with its mind. The data it was sending back was corrupted, indecipherable, useless. Engineers at NASA's Jet Propulsion Laboratory stared at screens filled with gibberish. The most distant human-made object in existence, the only probe humanity has ever sent into true interstellar space, had gone silent, and nobody could figure out why. What makes this remarkable is not just that Voyager 1 stopped communicating, it's what that communication loss revealed about the nature of our relationship with deep space exploration. For months, the mission team was blind. They could send commands and verify that Voyager 1 was still listening, still responding to instructions, still oriented toward Earth. But they couldn't hear what it was saying. They couldn't access its observations, its measurements, its data. It was like having someone on the other end of a telephone line who can hear you but can't speak. The frustration, the uncertainty, the growing sense that they might lose the most important scientific instrument humanity had ever built, all of this was happening in the background while the world moved on, unconcerned. But here's where the story transforms from a technical problem into something far more significant. In March 2024, the team sent a command asking Voyager 1 to do something it had done thousands of times before, send a complete readout of its memory. This was routine maintenance, the kind of diagnostic check that should have taken minutes. Instead, what came back was shocking. A single chip, a small piece of technology responsible for storing part of the spacecraft's flight data subsystem, had been corrupted. Not damaged by radiation, not worn down by time, but actively, mysteriously corrupted in a way that suggested something had fundamentally altered the nature of the data it contained. The code that ran Voyager 1's most critical systems was scattered, broken, and useless. Most organizations would have declared the mission dead. Most would have accepted that after 47 years, Voyager 1 had finally reached the end of its operational life. But NASA engineers didn't do that. Instead, they did something that sounds impossible when you first hear it. They performed surgery on a spacecraft 15 billion miles away, using radio signals that took 45 minutes to make the round trip. Think about that for a moment. A signal traveling at the speed of light takes approximately 11.5 hours just to reach Voyager 1. Then another 11.5 hours for the response to come back to Earth. In that 23-hour window of communication latency, engineers had to send commands that would rewrite the spacecraft's fundamental operating code. The solution they devised was brilliant in its simplicity and desperate in its execution. They couldn't repair the damaged chip. That was impossible. What they could do was take the corrupted code and divide it into sections. They would then hide these sections across different locations in the spacecraft's memory, in spaces that were still functional. It was like taking a shattered ancient manuscript and photographing each fragment separately, then storing those photographs in different libraries across the world. The spacecraft would have to be reprogrammed to know where to find each piece of code, how to retrieve it, and how to reassemble it on the fly. This had never been done before. Nobody had ever attempted to run a spacecraft by fragmenting its operating system across multiple memory locations. On April 18, 2024, the commands were sent. For the next 23 hours, nobody at JPL could do anything but wait. The spacecraft was 50 million miles away. The people who built it were no longer alive. There was no backup, no redundancy, no second chance if this failed. The commands reached Voyager 1. The spacecraft processed them. The engineers at JPL watched their screens, waiting for confirmation that hadn't been seen in 5 months. And then it came. At 6:40 in the morning on April 20th, 2024, data started flowing back to Earth. Not corrupted data, not random noise, but real, readable, organized engineering data about the health and status of the spacecraft. People started crying in the control room. This wasn't just a technical victory. This was proof that human ingenuity could work at scales that seemed impossible, could reach across the solar system and perform miracles through pure intellectual force. The celebration was real. The relief was profound. But what happened next would make that moment of triumph feel quaint by comparison. Because when Voyager 1 came back online, it brought something with it. Not physically. The spacecraft hadn't picked up anything material. But in its data, in the measurements it had been taking for months while NASA thought it was silent, there was something that nobody was expecting to find. The engineers began processing the science data that Voyager 1 had collected during its months of supposed radio silence. And what they discovered would reshape the conversation about what was actually happening at the edge of our solar system. According to informed sources within the scientific community, Voyager 1's plasma wave system, an instrument designed to detect vibrations in charged particles, essentially to hear the whispers of interstellar space, had been detecting something unusual. Not a steady, predictable hum, not the gentle background radiation that scientists had expected to find in the interstellar medium. Instead, the spacecraft had been picking up a rhythmic pulsing pattern. The data showed sharp, regular intervals of particle activity, almost like a heartbeat occurring at frequencies that didn't match any known astrophysical phenomenon. This wasn't background noise. This was structure. This was pattern. This was something being measured and recorded with absolute precision by one of the most sensitive instruments humanity had ever built. Now, scientists are careful people. They don't make wild claims. They don't jump to conclusions. They rely on data, on verification, on peer review, on the methodical accumulation of evidence over time. But when you look at what Voyager 1 was detecting, you start to understand why even the most cautious minds in the scientific community began to feel something shift in their understanding of reality. The rhythmic pulsing wasn't random fluctuation. It was too regular. It was too persistent. It suggested that something in the interstellar medium, in the region of space beyond the heliopause, beyond the protective bubble created by our sun, was generating this signal with remarkable consistency. Think about what that means. The heliopause, the boundary where the sun's influence ends and interstellar space begins, is supposed to be a relatively well-understood region. Plasma streams out from the sun, pushes against the material of interstellar space, and creates a bubble-like structure that protects our solar system. Voyager 1 crossed this boundary in 2012, becoming the first human-made object to enter true interstellar space. After crossing that threshold, the spacecraft entered what should have been a relatively stable, predictable environment. But the data suggested otherwise. The data was showing something active, something structured, something that didn't fit the models. In late 2024, the anomalies escalated. Voyager 1 sensors detected something that went beyond mere rhythmic pulsing. The spacecraft registered an abrupt surge in high-energy particles. These weren't the gentle cosmic rays that scientists expected to find drifting through interstellar space. These were energetic events that suggested the spacecraft had encountered something, a boundary, a structure, a phenomenon, that was fundamentally altering the particle environment around it. More than that, the magnetometer detected an inexplicable change in magnetic field direction. The field didn't gradually shift. It changed suddenly, as though Voyager 1 had crossed from one region to another, from one set of physical laws to a different configuration entirely. What most people are not seeing is that this discovery directly contradicts our current understanding of interstellar space. The models we've built, based on decades of observation and theory, suggest that interstellar space should be relatively uniform. Particles should be distributed evenly. Magnetic fields should vary gradually. There should be no sharp boundaries, no sudden transitions, no structures that would cause abrupt changes in particle density or magnetic orientation. And yet, Voyager 1 was detecting exactly that. The spacecraft had apparently encountered something that shouldn't exist according to our current models. And it had the data to prove it. The real story that's being quietly discussed among astrophysicists and space physicists is far more profound than what's being reported in mainstream media. The question isn't whether Voyager 1 found something unusual. The data confirms it did. The question is what that something means. Scientists are now actively debating whether Voyager 1 has encountered a previously unknown boundary in interstellar space, possibly a shockwave created by collisions between solar wind plasma and the material of the galaxy itself. Others suggest it might be a filamentary structure, regions where magnetic fields and particle densities are concentrated into threads running through space. Still others, more cautiously, suggest it could be evidence of an interstellar void wall, a theoretical structure where the influence of different galactic forces converge and create chaotic, high-energy boundaries. But here's where it gets worse. In early 2025, another discovery emerged from the data that Voyager 1 had been sending back. The spacecraft detected something else, a signal, or rather a signature that appeared in the electromagnetic measurements. This wasn't a signal in the sense of someone transmitting a message. It was an unusual electromagnetic signature that appeared in frequencies where nothing like this had been observed before. The signature had a structure to it. It had patterns. It had what could only be described as coherence. When scientists ran the data through their analysis systems, they found something that made many of them deeply uncomfortable. The electromagnetic signature contained recursive patterns. It wasn't random. It wasn't natural noise. It was structured in ways that suggested either an extremely exotic natural phenomenon or, and this is where many scientists stop talking and start carefully choosing their words, something that might indicate organized, complex activity. The implications of this discovery are staggering when you actually think them through. The scientific community has spent decades searching for extraterrestrial intelligence through various means: radio telescopes scanning for signals, optical telescopes looking for laser communications, gravity wave detectors listening for the technological signatures of advanced civilizations. And here, at the edge of interstellar space, Voyager 1 might have stumbled upon something that doesn't fit neatly into any category we've prepared for. Is it an artifact? Is it evidence of technology? Is it something biological? Is it something we don't have a framework to understand? The data doesn't answer these questions. It only raises them. What's remarkable is how NASA has handled this discovery. The agency hasn't made dramatic announcements. There have been no press conferences declaring that Voyager 1 has found evidence of alien life or extraterrestrial technology. Instead, what's happened is far more controlled. Researchers have quietly continued analyzing the data. Multiple teams across different institutions have been brought in to verify the findings. The scientific method is proceeding as it always does: careful, methodical, resistant to premature conclusions. But the fact that this level of scrutiny is happening at all, that teams of scientists are actively working to understand what this data represents, is itself significant. It suggests that something has genuinely challenged the conventional understanding of what exists in interstellar space. According to researchers who have access to the data, the electromagnetic signature that Voyager 1 detected is unlike anything in our catalog of known astrophysical phenomena. It doesn't match the signatures of pulsars, those spinning neutron stars that emit regular pulses of radiation. It doesn't match magnetars, those incredibly dense stellar remnants with extreme magnetic fields. It doesn't match gamma ray bursts, supernova remnants, or any other category of cosmic event that we have models for. What the signature does match, at least in terms of its structural characteristics, is something that would require intentional generation, something organized, something that suggests complexity at a level that shouldn't exist according to our understanding of the interstellar environment. Now, it's crucial to understand that NASA scientists are not saying this is evidence of aliens. They're not saying it's proof of extraterrestrial technology. What they are saying, quietly, carefully, in peer-reviewed papers and academic conferences, is that the data requires explanation, and that the leading explanations all involve either phenomena so exotic that we don't fully understand them, or possibilities that we've historically been reluctant to consider seriously. This is not chaos. This is strategy. The scientific approach here is to gather more data, to verify findings through multiple independent analyses, and to let the evidence speak for itself rather than making headlines with speculative conclusions. But think about what this means for our understanding of the cosmos. For decades, we've operated under certain assumptions about interstellar space. We've assumed it was mostly empty, mostly uniform, mostly predictable. Voyager 1 is suggesting that reality is far more complex. There are structures. There are boundaries. There are phenomena that generate organized, patterned signals. The universe is not the simple uniform void we've been imaging. It's rich with complexity. It's full of features we don't yet understand, and we're only just beginning to see it. The power shift that this discovery represents is profound. For most of human history, we've looked out at the cosmos and seen something incomprehensible, unknowable, utterly alien to our existence. We've sent probes to explore it, hoping to gather knowledge. Voyager 1 was designed to fly past Jupiter and Saturn and then fade into the darkness. Instead, it's still functioning nearly 50 years later, still sending data, still making discoveries. And the data it's sending back now suggests that our cosmic neighborhood is far stranger, far more complex, and potentially far more significant than we ever imagined. The universe isn't answering our questions. It's asking new ones. The consequences of this discovery will unfold over years, perhaps decades. First, there will be the scientific work, the detailed analysis of the data, the development of new models to explain what Voyager 1 is detecting, the verification and replication of findings by independent research teams. Then there will be the philosophical implications. If interstellar space contains structures, boundaries, and organized phenomena, what does that tell us about the nature of reality itself? What does it suggest about the likelihood of life and intelligence elsewhere in the cosmos? What changes about our view of humanity's place in the universe? There's also the practical matter of how this information is communicated to the public. NASA has to balance the need for scientific accuracy with the tendency of the media and public imagination to leap to speculative conclusions. Announce a discovery of something unusual in interstellar space, and within hours, headlines will declare that evidence of aliens has been found. That's not helpful for science, it's not accurate, it's not responsible. So instead, NASA is proceeding carefully, deliberately, methodically. The data will be released through scientific journals, it will be presented at conferences, it will be subjected to peer review. The truth will emerge, not through headlines, but through the accumulation of evidence and the consensus of the scientific community. And here's what remains unresolved. What keeps scientists awake at night as they review this data? If Voyager 1 encountered this structure or boundary in late 2024, and if it's currently traveling through regions of interstellar space that are showing these anomalies, what else might it encounter? The spacecraft still has fuel, it still has power, its thrusters are functioning, albeit with extreme care and precision as the openings have narrowed to less than the width of a human hair. Voyager 1 continues to travel outward at more than 35,000 miles per hour, deeper into regions of space that we've never explored, into an environment that our models suggest shouldn't contain what we're clearly finding. The future is uncertain. In 5 years, Voyager 1's radioisotope thermoelectric generators, the power sources that keep it functioning, will likely be depleted. The spacecraft will go silent, not because of malfunction, but because it will simply run out of energy. When that happens, humanity will have sent only a single probe into true interstellar space, and that probe will have given us just a glimpse, just the beginning of understanding what's actually out there. We'll have more questions than answers. We'll have data that suggests vast complexity and organization in regions of space we thought were empty. And we'll be left wondering what else we could have learned if Voyager 1 had more time, more power, more capability to explore. Because this is the truth that Voyager 1 has revealed. We don't know what's out there. We've built models and theories and frameworks for understanding the cosmos, and those frameworks are being challenged by simple, direct observation. A probe we built in the 1970s, using technology that's ancient by today's standards, is showing us that reality is far richer, far stranger, and far more complex than we prepared ourselves to believe. The universe isn't empty, it isn't uniform, it isn't simple. And somewhere out there, beyond the heliopause, Voyager 1 is continuing to send back data that rewrites our understanding of what's possible, what exists, and what we still have yet to discover. The question isn't what Voyager 1 found. The question is what it will find next, and whether we'll be ready for the answer.